The moment the sun finally moved out of the way, the James Webb Space Telescope locked onto something no one was ready for. 3I/Atlas was back. But this time, it wasn't just brighter. It was 4 times brighter than before, glowing like it had switched on an engine made of light. Webb recorded a glow that didn't behave like dust, ice, or gas. It moved in smooth, intentional waves, almost as if the object was adjusting its own surface to the heat pouring off the sun. When astronomers sharpened the images, a new shape appeared, perfect hexagons arranged in a metallic grid, a pattern way too precise for any natural object drifting in deep space. And before anyone could process that discovery, another shock arrived. A faint ultraviolet flash pulsed every 247 seconds, perfectly timed, like a coded transmission rather than a random natural cycle. Nothing about this matched a comet. Nothing fit the rules. So if 3I/Atlas came back brighter, sharper, and more controlled than ever before, one question now dominates the conversation. Why did it return? The history nobody expected. Long before this new appearance, 3I/Atlas had already earned a strange place in the short history of interstellar visitors. Only 2 objects before it had ever entered our solar system. Oumuamua, 2017. The cigar-shaped mystery that left scientists debating for years. Borisov, 2019. A more typical ice comet that burned bright and moved on. Then came 3I/Atlas, the 3rd confirmed interstellar visitor in human history. And from day one, astronomers felt something was off. The Hubble Space Telescope, observatories in Hawaii, Europe, and dozens of ground-based instruments tracked it night after night, a level of coordination normally reserved for spacecraft, not comets. Its orbit felt wrong. Its brightness felt wrong. Its trajectory didn't match anything in the textbooks. Something about it refused to behave like a natural object. And then, it vanished. Just when the data started hinting at deeper mysteries, 3I/Atlas slipped behind the sun. For months, telescopes saw nothing. Not a flicker. Not a stray photon. It was a perfect blackout. Astronomers worldwide admitted they had never seen an interstellar object vanish so completely. And the timing made everything worse. The sun's glare is the one place where anything can change shape, direction, or structure without anyone watching. Then suddenly it returned. And what came out from behind the sun was not the same object that went in. Brighter, colder, controlled. The first data stunned every research team. Its brightness jumped 400%, but its temperature stayed perfectly stable, something natural comets never do. Its reflectivity looked like the surface was regulating heat, shifting panels the way satellites protect themselves in orbit. No comet acts like this. Nothing natural behaves this way. And then scientists saw something even more shocking, the impossible anti-tail. When comets get close to the sun, their tails stream away from it. Physics 101. But 3I/Atlas? Its tail pointed toward the sun. An impossible anti-tail, confirmed by Hubble, KEK Observatory, and multiple European telescopes. It wasn't drifting. It wasn't wobbling. It held a steady line, like it was being guided. Natural gas jets scatter chaotically. This one looked anchored, almost like a thruster plume. For many astronomers, this was the first sign that 3I/Atlas might not be acting on its own. Metal, cyanide, and something hollow inside. When the spectral readings arrived, the numbers were shocking. The object's surface reflected a refined nickel-iron alloy, cleaner and purer than any known comet. It also carried cyanide compounds locked into its structure, extremely rare in interstellar dust. Then came the biggest surprise. The brightness patterns suggested the object was hollow. Not a chunk of rock. Not a ball of ice. Something structured. Something built. A shell with empty space inside. Piece by piece, the evidence pointed in one direction. Maybe 3I/Atlas wasn't made by nature at all. A jet that looked like propulsion. A small observatory in Spain captured 159 frames of 3I/Atlas, and what they found stunned the world. A narrow, needle-straight jet streamed from one point on its surface. It didn't scatter. It didn't flare. It fired like a steady engine. Frame after frame, The jet stayed perfectly aligned as the object rotated, and every time it fired, the trajectory shifted in tiny, controlled increments. Not random, not chaotic, controlled. For many researchers, this was the turning point. It didn't look like a comet drifting. It looked like a vehicle steering. The 247-second signal. When 3I/Atlas returned, it brought something no one expected. A signal. Ultraviolet flashes, perfectly timed at 247-second intervals. Natural bodies don't keep time like that. When scientists decoded the first sequence, their jaws dropped. It mapped directly onto prime numbers 2, 3, 5, 7, 11. Then the final burst lasted 13 minutes and 37 seconds, forming a pattern aligned with the golden ratio. The mathematical fingerprint of galaxies, hurricanes, seashells, and living structures. Embedded in the spiral were binary markers, repeating like instructions. SETI researchers knew exactly what it looked like. A deliberate message. The final move. When the signal stopped Atlas to drift away naturally. Instead, it made one last move. A 0.09 degrees course correction, tiny, but impossible for a natural object. Moments later, its speed began to rise, smoothly, intentionally, and then it left the solar system, not drifting, not falling, departing, as if its mission here was complete. So what was 3I/Atlas really? A comet? A probe? A visitor? A machine built by a civilization older than ours? Whatever it was, it didn't act like a rock. It didn't behave like ice. It behaved like something that came here with purpose, and then left.